You should have something out to write with. You should be ready to go. We're going to talk about these quizzes. Okay, the first one we're going to talk about is quiz 4-1. Oops. So quiz 4-1, whether you have one or not, you should still be paying attention and you should still be taking notes. Okay? So find something to take some notes on. Yes, in your notebook. Yep, that's where you should be taking your notes. Okay? All right. 4-1. One of the questions on there asks about the periodic table. And it says the periodic table is arranged according to increasing protons or atomic number. By definition, the atomic number equals the number of protons. Okay, that is its definition. Your protons have a positive charge. So if we did like a chart here comparing these, okay, your protons charge would be 1. Plus positive, I guess it should be. It should be positive, shouldn't it? Protons charge is positive. Its mass number for a single proton is also 1. And its location, which is another question on there, is in the nucleus. There is another subatomic particle that is also in the nucleus. That would be the neutrons. Okay, that is also in the nucleus. Its mass number is what? 0. And its charge is, no, its mass number isn't 0. Its mass is 1 and its charge is 0. There we go. Okay. Electron. Charge on an electron is what? Negative. Its mass is so small we don't bother with it. And it is outside the nucleus. The location of these was either tested in or on the quiz, either in the multiple or matching section, or it was tested on the back side where it asked you to list the 3 subatomic particles, depending on what variation of quiz you had. All right, so considered to be the father of the periodic table, who would that be? Mendeleev, good. Again, I wouldn't ask you to just pop that out of your head, but if you were given a listing of people, you should be able to pick that one out of a list. Okay? Mendeleev, yep. M-E-N-D-E-L-E-V. That is the father of the periodic table. We also had this guy on there. Sorry. Let's try that again. There. A over Z and then an X next to it. Okay? And we asked you what each of these letters represented. A represents what? Protons. Mass. And our mass consists of what? How many protons plus how many neutrons we have. Right? Z represents atomic number, and it is equal to the number of protons. Okay? We asked, one of them was the mass of a neutron is approximately equal to the mass of what? Yeah, a proton. The neutron's mass is approximately equal to the mass of a proton.
But didn't it say these two?
That was the one that said these two. It says the atomic mass is calculated by adding these two particles. So adding the two particles that you would need to add would be proton and neutron. Now, I would not accept atomic number in neutron. Why? It's not a particle. Okay, and it said the two particles. All right, any other questions on that side of the quiz? Anybody that still has one of those to take? I think I've gone through everything, but just verify that. All right, the back side, you had to identify the three subatomic particles. So there's the three. And then we also asked on some of the versions for the put a star by the particles that are in the nucleus. So you would have put stars by these two, or the particle that's outside the nucleus. So there was four different variations on the quiz, depending on which one you have. All right, the next one, it asks for isotope notation. It asks for the isotope. It asks for the atomic weight, the number, and then protons, electrons, and neutrons. All right. So the isotope. Wait. Isotope notation. I'm just going to do one for lithium here. Okay. This is isotope notation for lithium. We tried to show you on the quiz a couple examples of what we wanted when we were talking about isotope. And the way we had that done was we had the abbreviation, the symbol for the element, followed by its mass. All right. Atomic weight then is going to be the 7 again. Atomic number is what? 3. That's this number right here. That is your atomic number, which is also the number of protons. Now, in an atom, which these were, our protons will equal our electrons because it is neutral. We have the same number of positive charges as we have negative. So this will also be a 3. Now, neutrons, the way you figure that out is you look over here at this. This is protons and neutrons. So this is protons and neutrons. This is protons. So if I want to figure out neutrons, what do I need to do? I need to subtract. If this is both and this is 1, I need to subtract to get the other one. Yes? Yes. Mathematically? Does that make sense? Drew, where are you? Good place? Okay. All right. All right. Any other questions on that? Okay. So that was 4.1. Any other questions on 4.1? Anything that's confusing on there? All right. 4.2. And this will get some of you, if you're not paying attention to this 4.2, you need to kind of think about this guy and work with him. So this is coming up. You will have one of these on the free response section of your test. Okay? So you need to make sure, even if you've aced this one, take notes on this because this is going to come up again. So you need to be comfortable with doing this. Okay? All right. So this is for, there we go. This is going to be 4.2. All right. So on here, we had X20, X21, X23. Next to those, we had 19.9924. We had 20.9928 and 21.9914. This was the mass. This was the percent. Percent is going to be for this first one, 89.48. Well, 1.27, that's not a 7. Let's clean some of this up while we're at it. 89.487. There we go. And then 9.25. So step 1, you are going to divide percent by 100. Step 2, multiply step 1 by mass. And step 3, add step 2 values, answers together. Okay, so I'm going to divide these by 100. So this divided by 100 would be 0.8948. This guy would be 0. What? 0.127. Yeah, 0.127. A lot of people forgot. They just did this in their head, and they forgot that 0 there. So they did 0.127, and that would not be correct. And this one will be the same way. So be careful with those. Okay. So this is step 1 right here. I have done step 1 in red. Step 2, I am going to multiply my mass and the thing from step 1 together. So these two things are going to get multiplied together. I'm going to multiply this thing with this. I'm going to multiply this thing with its percentage divided by 100. Then what do? So this was step 2. Then what do? Add them together. I'm going to add these 3 values together, and that ends up being 20.19. And I did that in green. Now, what should I do next? Check my work. Yes. I'm not going to do anything else with this number unless it's wrong. Okay? So check number 1. Is this value between your lowest and your highest value? That's our first check. If you had screwed up on this and ended up with this being right here, this step right here, that'll catch you in this part right here. That checking between there and there, it's going to catch that error. Remember, a lot of people did this as 0.127 instead of moving it 2 spots over. It'll catch that error. Lastly, we are going to check and see if this value is the closest to the value that we have in the highest percentage. So this is our highest percentage value right here, 89%. This is fairly close to that. So that's our second verification check to make sure that everything went right. Okay, makes sense? I was getting answers on this one like 35, 39. I mean, they were just kind of all over the place. Some people just didn't even do it. This shouldn't be too bad now that you understand the steps, right? Does anybody have any questions on 5 or 4.2? Good? All right. I want to move on then to 5.1. All right. So again, the varieties of this kind of varied from, which version you had, but on each version, the first problem had some sort of wavelength that you had to convert into nanometers, or from nanometers into meters. So in this particular version, we have 450 nanometers, and I need to convert that into meters. And I want you looking at the chart that you looked at when you took these quizzes. So we can make sure that you understand. Oops, we got somebody else back there. How many do you have now?
We need one for Bailey.
I think that's it now. I know. 1, 2, 3, 4, 5. 1, 2,
Thank you so much.
3, 4, 5, 6.
I don't know what this one works.
All right.
I don't know. Yeah, I don't know.
So you should be looking at your formula sheet. On that formula sheet, on the chart off to the side, it says nano. It says factor at the top. And it says prefix. And it says symbol.
Are we getting this paper for the test?
Yep. Okay. So nano, the factor says 10 to the negative 9. The prefix is nano. And the symbol is little n. Okay. Everybody good with that?
Yeah.
Okay. So you are going to look at that, and you will see that we have these. This is set up. Okay. So this is, if I had 1 meter, or I'm sorry, if this is what it is for the meter. So 1 times 10 to the negative 9 meters would equal 1 nanometer. All right. So I need to get rid of nanometers. I am going to put this in there. So nanometer and meter. 1 times 10 to the negative 9 and 1. Do you see how to read that chart?
Mm-hmm.
All right. So I put that in my calculator, and you need to get comfortable with your calculator. Okay. Some of you, I think, are starting to drive at this point, right? Every car that you get into that you have to drive is a little different than every other car. Okay. You have to figure out where the windshield wipers are. You have to figure out how they work. You have to figure out where the gear shift is. Sometimes it's on the steering wheel. Sometimes it's down by your side. Sometimes it's not even a stick. It's a turn dial. Have you seen any of those before? Okay. So you've got to figure out every time you get into a car how to drive that car. Everyone's a little different. Calculators are the same way. Okay. There is a learning curve. You need to be comfortable with your calculator and how it works. Okay. You don't need to be grabbing one out of my bins every time you need one and end up with a different one, and then you don't know how to use it. It's like switching to a different car every time. You want to be comfortable in the one you have. Does that make sense? Mm-hmm. So get one and get comfortable with it, because if you don't, you are going to have a lot of problems. Okay. All right, so when we are looking at those, when we're working with this, you're going to be putting that into your calculator. You should come out with this as your answer for your nanometer, for your meters, I mean. Okay? So hopefully you're able to get that to come out for you. Now, we also have on that sheet a couple equations. The one that we're going to be using for 5-1 is, it looks like this. Okay. Now, we need to arrange this so we are solving for this guy. If you need to, I don't know why that looks funky. Okay, there we go. If you need to, put a little dot in between these to remind yourself that you're multiplying. Okay? I need to isolate this by himself. What do I do?
Divide by it.
Right, I'm going to divide by wavelength here, and I've got to divide by wavelength over here. That's going to get me my frequency on one side and my speed of light, which is c, over wavelength on the other. The speed of light, c, is on your formula sheet. it is equal to 3 times 10 to the 8th meters per second. Okay. Then I'm going to take my wavelength that we just figured out up here. It will be 4.5 times 10 to the minus 7. And that would be meters. So when I get done here, my meters will end up canceling, and that's going to leave me with 1/seconds for my answer. So you should have ended up on this one at 6.67 times 10 to the 14th, and that would end up being 1/seconds or inverse seconds. Or what else does it equal? Hertz. Hertz are inverse seconds. Any issues or problems, anything that doesn't make sense on that guy? All right, let's keep plugging away then. Control Enter. What's wrong on here? Do I need to put what? If you put down this, if you put down seconds, it has to be to the -1. Yeah. You can't just, because, what? Yeah. Yep. You can't just put seconds down here though, okay? Because remember what frequency is. Frequency is how often something has happened in a given period of time. So your birthday, the frequency of your birthday is 1 per year. 1 birthday per year. The years are on the bottom. Okay. How many quizzes do we have? Usually about 2 quizzes per week.
I zoned out for 2
1
seconds.
week.
What are we talking about? Quizzes and weeks? Oh, okay.
We're talking about what frequency means.
Got it. Yeah, I don't frequency. I was just confused. I zoned out for like 2 seconds.
Was it for like 2 seconds?
All right. So you can't just put down years there, because if I asked you what's the frequency of your birthday and you said, you know,
Year.
Birthday, one year, it's like, no, it's 1 birthday per year. Does that make sense? Okay. You get 2 birthdays?
Yeah.
Okay.
I get 3. You got drip.
Glad I'm not your mama.
Stop.
Just saying, 3 birthdays, that'd be rough. All right. So we are on to the second problem on there. That one should have been a fairly easy one. You were simply calculating the frequency if you were given wavelength or vice versa. So this one, on this quiz that I have, we are calculating wavelength. So we're going to take this formula again. Okay. And now we are calculating this. Okay. So I need to get it by itself. So I will simply divide both sides by the frequency. And we will end up with wavelength equaling the speed of light over frequency. Okay, I'm going to go plug my numbers in. Again, C is on your formula sheet. 10 to the 8th meters. And then on your formula sheet, it says this. So that's meters. And then where are your seconds supposed to be then? Underneath. It means wherever your number is, that unit goes on the bottom. So meters per second. Then my frequency is coming in. And that one, it has 3 times 10 to the 19th hertz. So if my number is here, the seconds have to go here.
Quick question.
Yep.
So when you're solving for wavelength, can you just like assume that it's going to be meters?
Yeah, you should. Yeah. It's always good to put your units in your problem, because then if you end up solving it and you solve for something other than meters, that means you got something out of place. So if, for example, I had this guy up here, right, then that seconds would be down here and it would be meters per second square, and that would not be correct. So it will catch you when you have those errors. All right, when we do this, we end up with 1 times 10 to the negative 11. And our seconds will cancel. That'll leave us with meters, and there's our answer. Everybody happy with that?
Yeah.
Okay. Any other final questions on quiz 5-1? Okay. I will then turn my attention over to quiz 5-2. Now, this one, a lot of you struggled on it.
Guilty.
What?
Yes.
Yeah. So this is 5-2. I'm going to do Bunsen burner. All of them were the same. All I did was change the number. Okay. So this is asking us for the energy of a photon. We have on our quiz, or on our formula sheet, we have this guy. It has energy, which we need. That's what we're solving for. It also has frequency, which is what we were given in the problem. So this is the equation that we're going to use, and it's already set up for us. We don't even need to rearrange it. Okay. I'm going to start off with Planck's constant. Planck's constant is given to you on the formula sheet. That is joules times seconds. I'm then going to multiply by the frequency that was given in the problem. So all I'm doing is taking that number from the quiz and I'm just rewriting it. It is hertz, which means wherever my number is, my unit is on the opposite side. So my seconds will cancel, and that's going to leave me with units of joules. And I got that too close. I didn't give myself room to write there. So let's try this. We're going to write our answer down. That is 4.37 times 10 to the negative 15, and that's going to be joules.
It smells like popcorn. You should let us use this on the test.
Yeah.
Yeah, if you turn it up, it would be helpful. It's just this one page. It'll help me a lot.
All right. So this is joules per what? Per photon. Because it says in the problem, what is the energy of a photon? Energy of a photon. So this is going to be per 1 photon. They wanted us to give our answer in kilojoules per mole. Okay? So I gave you, out of the 10 points for the quiz, I gave you 4 points if you could get this answer right. Okay? So we need to convert this out of joules. Okay? On your formula sheet again, it says, and we're going into kilojoules, it says 10 to the 3 kilo and K. That means that 10 to the 3 is what? 10 times 10 times 10 is 1,000. So 1,000 joules equals 1 kilojoule. I'm going to put my joules down here. Kilojoules.
Like just looking at that thing. How did you know that we needed to use kilo?
Because it wants us to convert into kilojoules
right.
per mole.
Yeah, you're right. I'm sorry. I know it. Right.
Okay. So we're trying to get to this unit. Right now, once we plug these numbers in, at this point, we're kilojoules per photon. I need to get out of photons. And it doesn't matter what it is. It's just like a dozen, okay? A mole is like a dozen. You can have a dozen pens, a dozen photons, a dozen monitors, a dozen mice. It doesn't matter. That's what a dozen is. It's 12 of everything, okay? So if we have 1 mole of photons on your sheet, it says Avogadro's number is 6.022 times 10 to the 23rd mole minus 1.
Does that go where photons is?
Yep. So that would be, this is how much you've got per mole of whatever it is. In this case, it happens to be photons. It could be Landons.
What?
It'd be a lot of Landons. And that's going to get rid of photons then. So photons are going to go, joules will go, and that's going to leave us with our answer. For this one, it ends up being 2.63 times 10 to the 6th, and that's going to be kilojoules per mole. Did that help some?
Sure.
Okay,
It's a lot.
I understand. Okay,
I don't
what?
think Bailey gets it.
No, she's having a conniption fit over there. What's going on?
No one's good.
No, you're not.
Yeah, I got it.
No,
Did I get the quiz? No.
Do we believe her?
No, we don't.
I'm good.
Is anybody else still not understanding what's going on here? Talk to me so I can help you. I am literally begging you to let me help you. I just need to know what you don't understand so I can explain it better, okay? I'm struggling to make sure that you guys know how to do this, okay? I need you to help me, tell me what you're not getting and why you're not getting it, okay? And it's not an accusation of anything that you're doing wrong. I'm not trying to demean you or anything, okay? Obviously, if this many people are having this kind of trouble with it, you know, I haven't been presenting it to where you need it to be. So tell me what you need. What doesn't make sense? What is overwhelming to you?
Wait, it just clicked.
Okay.
Wait, yeah, because that over that is, yeah.
Okay?
Yeah.
All right. Now we believe her?
I think
Okay.
so.
All right.
Heard the light bulb.
So the last one that you had on this was the energy of electron if they gave you wavelength. So we have 2 different formulas here. We have this guy and we have this guy. Okay? You're going to need both of them for this. Okay?
Double whammy.
You are solving for this, but they gave you, oops, hold on. Hello. Sorry. There we go. But they gave you this. Yes, you've got to get this by itself. Okay? So what I'm going to do is I am going to get my wavelength on one side, and by dividing both sides by this, yes, C over V. Now, I can take this, nope, not C over V. What did I do? Shoot. I need to get that by itself. They gave us this. I need to get this by itself.
Oh, no. What do you mean, no shoot, Bailey?
Okay. I need to get this guy by himself. Yeah, there we go. Okay. Now I'm going to take this and I am going to insert it in the place of, yeah, I know that kind of freaked me out too, of this guy. So all of this is going to go in place of this. I'm just going to pick this up and I put it right here.
Why are they both divided by the y if it's is that wavelength?
This is what V equals, so we're just sticking this in the place of V.
I know, but they were multiplied, so why are we doing that? Like right here, like this, the C and the H. They're
How did the
multiplied.
H get on top?
Right, that's what I'm saying.
Okay, so this is the formula.
Yeah.
Sorry. The formula is H nu. Okay? Nu, this equals this.
Yeah.
So I can take this away, C's on top, and wavelengths on bottom.
Oh, okay.
Yeah, I wrote it like H.
Yeah, no.
Yeah, wait, why is it H by itself though?
You could, I mean, you could write it like this. You could write it H times C over that.
That's just gonna make more work for you though.
It doesn't matter. It's the same thing.
Sorry, I'm tired. I got the giggle.
Got it. Did it click? That part clicked.
This is better?
Oh, yeah.
No, talk to me.
Yes.
Okay, all right. Part of it is that,
It's your fault.
well, I don't know how to teach algebra. Like, I haven't been taught how to teach algebra, okay? I've been taught to teach chemistry. Like, when you come to me, like, you know, and this is no fault of your own. It's just the way the system is nowadays. It used to be that, like, this just was all intuitive because you had done it for so long. Because they started you, like, in 7th grade with pre-algebra, and then you did algebra in 8th grade, and then 9th, you know. And so by the time you got to me, this all was, like, solid, okay? That's not the case anymore. But I haven't been taught to teach algebra. I've been taught to teach chemistry.
Oh, so you're trying to teach
And
us
so
to confuse
I'm trying to teach you how to do algebra the way I learned to do algebra, which was a very long time ago. So
like 10 years ago.
I've been, so I like literally went to one of the math teachers and I'm like, show me how to teach algebra. So this is like with this dot here, you know, she's been talking to me about doing that and just some techniques to try to help you guys out, because I know that if you're not getting this, it's because I'm not explaining it the way you need me to explain it. Okay. And that's why I've been struggling with this, but I need you to tell me when you're not understanding something and not just get frustrated and give up, because I'm trying to solve a problem too. It's just a slightly different problem than you are.
Got it.
Okay. But I need you to communicate with me as to what you're not getting, because otherwise I don't know how to fix it. It's like taking the car in and saying my car doesn't work.
Nope.
And they're like, okay, what's wrong with it? It just doesn't work. It's like, no, the tires are flat, the oil's leak. What about it doesn't work? Oh, it's the window won't go up and down. Okay, now we can address that. You know, I need a little bit more specifics. So, and I need that from you guys. Okay. Yes, I want my quizzes back. And I want my formula sheets back too. All right, so this is where we're going to pick up tomorrow.
Are we going over quizzes again tomorrow?
Yes. And if I have to bump the test to Tuesday, by gosh, I'll bump the test to Tuesday.
Yeah, let's do it Tuesday.
She went over all the quizzes on the
I get 5.2.
Where do you want us to put that?
Why don't you make a pile of one, like go around and grab them. Pass your quizzes up. Pass your quizzes up.
Want me to just take one?
Yeah, and just make grab. Yeah. Make 2 piles, quizzes and formula sheets.
Thank you.
7th hour.
I understand. Sorry.